Hello, so we're back, and this time we have a nice laptop to repair. It's a Lenovo Yoga, yeah, nice sticker, S740, i7 engine and IRX graphics. Now this job is coming from a computer business, and what they are saying, Lenovo Yoga, when pressing the power button, the light on the power switch comes on, then goes off and won't turn on. So basically, it's coming on for a short period of time and goes off. Basically that. I will say, let's plug a charger and see what it's doing. Pressing the power button, nothing happened. Let's see if we can help them. Yeah. Now the charging port. Wait, we have a round charging port, not USB-C. Lenovo, which must be this one. Yeah, it is. So 19 volts. Hopefully we have some current there. Plug in the. Wait, I heard a click on the power supply. 1 second. Yeah, we have like 1 amp. Let's raise the current. Like 3.3 should be fine. And it's taking 350 milliamps, 1.5 amps. So the laptop start 1.6 amps actually. Why the current is changing? The laptop is trying to start because this is not the charging current. Pressing the power button and the power supply clicked. You know what? This is a weird case. Let's open the laptop and check the coils first, because some random things happen, and the point is to not damage the laptop more. Now, if you ask yourself, okay, how you can damage your laptop more? Customer already plugged the charger. The charger has a limited amount of current. You pass over, like, let's say 3 amps, the charger, it will shut down. Not the power supply, yeah? The power supply will just limit the current, and, the voltage is getting lower and so on. So even if you don't have enough current on the power supply, it will not switch off, at least my one, the linear one. Can you burn a laptop by having the voltage, having like a current limit? Then the voltage, obviously the voltage is going down because you don't have enough current. Yeah, it happens. Years ago, I have the power supply like low voltage, and I plug the charger, and I came with the power supply. Then I raised the voltage of the power supply from 9 to 19. And at some point, I see the current going high, and yeah, the board got shorted. It was the LDO power supply chip who got shorted. So yeah, bad things can happen. Good. Let's try to open the laptop. And the laptop is open. Yeah, that's a nice motherboard. Check here, we have a seal there. So no one took the motherboard out. It's nice when you are the first, touching something. You're like a brand new product, or you open a laptop and it's sealed, no one touched it before. You know the feeling. So here you have a power button. Actually, here we have a button. Let me press the button. Yeah, I press the button. And not sure what we can check. I said to check the coils, you remember? Yeah, we have a bunch of coils here. Here we have one more RAM. This laptop has a dedicated GPU. Wow. I didn't expect that. So, let's unplug the battery. And the battery is unplugged. Beeping mode. Let's see. So this coil is good. This coil is good. This coil is good. Looking good. So what's the problem then? Let's plug the power without the battery. Plug in the power, and it's taking like 140 milliamps. And it's going back to 0. It's like, the laptop is trying to do something. The problem is I can't see the laptop coming on like the customer said. The customer said it's coming on for a second and it goes off. I can't see that. So my question is, what is taking 130 milliamps? Let's see. I mean, I want to know where my current is going. Pressing that button. Yeah, nothing happened. Let's wait. And we have the thermal camera. And what is that? 1 second. So here is something which is taking current. Then here is a reflection. Wow, what is that? Check that. Ooh. This chip. Oh, lol. Lol, actually it's hot. Let's see what that chip is doing. Has a BIOS chip next to it. Do you think it's the PD controller? Actually, it is the PD controller. So the PD controller is getting hot. And we have a memory chip next to it. And now you'll ask, okay, sorry, but how the PD controller can get hot if you plug the charger, like the round pin charger? And the thing is, it's taking basically, you have USB-C. It's coming to the PD controller, and the PD control from the PD controller to the main power rail. Means if you plug the power here to feed the main power rail, the power from the main power rail can come back to this chip, and if this chip is shorted, it will get hot. Exactly what is happening here. Let's plug a USB-C. 5 volts, 100 milliamps. What do you think is taking 100 milliamps? Actually, 200 milliamps. 200 milliamps is taken by the chip itself, because obviously it's shorted, like I said. It's not completely shorted, it's like partial shorted. Check that. You can see? So that chip is taking actually this current, yeah? Now let's plug the charger and let's check the main power rail just to be sure. Main power rail have coil, chip, capacitor. And we have 17.5. Check that. You can see on the screen? Yeah. So the main power rail is present. I think the fault is quite clear. Yeah, the PD controller is dead. If the PD controller is dead, the laptop it will not come on because that chip is speaking with the ECU chip, and they have to speak. Otherwise, the laptop it will not come on. Bad design. I mean, everyone thought, yeah, it's USB-C. Yeah, this is like it's a upgrade. It's a improvement. Actually, having this kind of poor RAM pin, you can do whatever you want. Having USB-C, end of story. I mean, even if you don't use the USB-C, you use this one, it will not work if this chip is faulty. If you don't have this port, it will be the same thing because it will not work anyway. So yeah, it is bad. Just think, if it wasn't a USB-C here, so that means not USB-C, no chip, that means the laptop it will work on the RAM pin, yeah? So this is a TPS 65988 DJ, and that DJ is important. Let's take the chip out. Let me use a little bit of rosin. I mean, the idea it was good, but the manufacturer comes with like inbuilt software, pre-programmed chip, and all that kind of things. So when you have a chip like this, there are a lot which has to be pre-programmed, and you cannot pre-program a chip because you don't have the firmware. You don't have the tool to program the chip. Yeah. So even this one, not sure if this it will be a repair, because I'm not sure if this chip has to be pre-programmed or it will take the program from the memory next to it. Yeah. So not sure about that. So what do you think? Can we found a chip like this on our box? Let's see. Can I found like a brand new chip TPS 659A70? No, it's not that one. Okay, we don't have the chip in the box. I think I cleaned the things a few days ago. I tested them and it was not working. So we have to find the chip on a spare motherboard. Yeah, yeah, just give me 1 minute. Okay, I don't have another one. That's the problem. So what I will do is I will order one. And hopefully it will not be like a fake chip. Hopefully it will work. I will let you know anyway. 100% positive. Yeah, let's buy it. Good. So I'm gonna stop now and see you when the chip arrive. Yeah. Bye. So we are back. I just came out from the swimming pool. Outside are like 29 degrees. You can believe that? I had so much fun because it was the first bath of the puppy. So puppy knows how to swim. So I'm happy. Anyway, the chip arrived and we have to feed the chip. Yeah, let's fix quickly the laptop and let me go back to the swimming pool. 29 and tomorrow is like over 30 degrees in England. You can believe that? Insane. So if I remember, we took out the chip, right? Yeah, the chip is out. It is. Uh, okay, we have solder, we have flags, so that is fine. Let's get a new chip. Same chip. Brand new. Before we are soldering the chip, let's apply some solder onto the pins, just to be sure, we are soldering every pin. Rosin and yeah, too much solder. Yeah. The solder is getting nicely onto the pins. Perfect. I think we are ready to solder the chip. What do you think? Chip position, hot air, and the chip. It is soldered properly on place. Yeah, 100%. We do have some solder balls here, but otherwise it's looking good. I think it's time for testing. So, let's cool down the chip quickly. Let me grab the USB-C, power meter, plug in the charger, and the meter it is coming on. Wait, what happened with my meter? 4 volts, 5 volts. Okay, that's bad. That's actually very bad. What's wrong with my meter? 5 volts. Okay, that's not good. No, no, that's not good. I mean, it's not taking current anymore, so yeah, it's not shorted, but it's not working. And now I'm asking myself, has to be program or not? No, I have no idea. Okay, let me plug the battery. So the battery is plugged. Let me try to push some current into the battery. 19 volts. That's crazy. It was not working. Ha! Okay. Okay. We are good. So, pushing some current. Yeah, let's go less. Pushing some current into the battery, and it's taking 2.6 amps the battery. Check that, 2.6 amps. That means the battery is charging fine. But why the laptop is not charging by the USB-C? Do you think it has to be powered first, to program the PD controller? Can be. Okay, let's try to power on the laptop. So, pressing the power button, and the laptop is coming on. Check here. Check here, it's on. But it's taking no current. Check that, no current, nothing. And the power button is flashing. Huh? Okay, I don't understand. Look, this doesn't make sense because the PD controller is working. We have 19 volts. The problem is the PD controller is not passing the voltage to the main power rail. Let's check the main power rail. What did you said? Dodgy solder? No, that cheap? Nah, no way. But yeah, we're gonna check that. The heatsink is hot. Wait a second. Okay, the laptop is off. But the heatsink is warm. Anyway, the main power rail is... The main power rail is 0.5 volts. How the main power rail can be 0.5? Wait, 1 second. Maybe I'm doing something wrong. Here you have a power supply. Check here with 4 MOSFETs, as you can see. So this coil is creating the main power rail. Here you have a current sensor when you have 0 volts. So the input here, 0.4. The input, okay, not sure where is the input, but let's check together. So this is the power supply which is creating the main power rail and is charging the battery also. Yeah. So the input here is 0 volts, okay, and here the output is 0.2. So it's either this one is the input and this is the output, or other way around. Okay, so the problem is the PD controller is working, but it's not outputting any voltage. Why? You remember that big pads which I didn't solder? Yeah, that big pads are for input output. Here you have no voltage. How we can have no voltage on the PD controller? Here we have, okay, the BIOS chip, this one, we have 0. Pin number 1, which is, okay, which will have like 3.3, something like that, okay, nothing. Here we have 19, 20 volts. So I'm assuming here is the input, and the output probably is somewhere here. Okay, let's do another solder job. Okay, let's do it one more time, yeah. Yeah, it's okay, even if you have to solder the chip twice, it's fine. Here is no competition. Lol, my chip ran away. Good. We do have some extra solder there, but that's fine. It's looking good. Let's check one more time. But I'm happy the PD controller is working. I mean, kind of like partial working. Plug in the charger, and the meter is coming on. 5 volts. Okay, I hate that. And you know why? Because the AC chip doesn't have power. Because this chip is not passing the voltage to the main power rail. And if the AC chip has no power, It will not speak with the PD controller. That's the only reason. So now I plug the battery, and obviously the main power now is present, and now I will have 19 volts. Or no? No more 19. No. Let's press the power button. Pressing the power button and nothing happened. Okay, that sucks. Yeah, everyone is on the swimming pool. They have fun. Only I have to work here. So it's taking 2.6 amps, the battery. So if I check now the main power rail, the main power rail has, so this is the input clearly. Then this is the output. The main power rail has 14.5. No, it's not working. I can't believe I'm doing something wrong. I mean, we soldered that chip, right? Twice. It was working once. Okay, so the chip it is soldered, right? I mean, check here. Every pin is soldered. You can see every pin is soldered. There's no reason for this chip to not work. No. Good. Perfect. That's a perfect solder chip. And I'm not gonna take that chip out again. No, because it is soldered properly. No, must be a different issue. Yeah, definitely. Plug in the charger. We have freaking 5 volts. I can't believe. The meter is start. And we have 19 volts. Check that. I told you the PD controller is working. But obviously it's not charging because we have no input voltage. Just to understand. So here must be the input voltage. We have 0 volts. 0, 0, 0. Nothing. Nothing. So the voltage is getting lost from here to here. Yeah. That's what is happening. So I should have 19 volts here. Okay, you know what? Let me try with some low voltage first. So here and here. And no, it's not sure. No. So check here. If I come with 19, it will start charging. Can you believe that? So 19 volts. Here. Check on the screen. Check on the screen on the power supply. I don't have enough current. Okay. I'm coming on the current sensor. Check that. It's taking like 2.7 amps. You can believe that? 2.7 amps. So I don't want to be dodgy, but we can use one wire from the 19 here, and the problem is solved. I think the laptop is coming on. Oh lol, the fan are spinning. Check that. The fans are spinning. We have a picture. That's crazy. Let's use a wire. Yeah, let's trap that thingy. Because I have no explanation why the 19 is not reaching this current sensor here. Yeah, the fans are spinning. Yeah, you can hear the window sound? Yeah. So basically this track is coming to the PD controller. This one. You see here the dots? Yeah, it's going on the other side of the board and it's coming exactly here. So here we have 20 volts. Yeah, here must be the... But we're gonna find out together soon. So this one is 20 volts. This one is 0. And this is freaking pretty strange. Why I will have 0 volts here? Why 0 volts? I mean, what's the point having capacitor if you have 0 volts here? Just say it. Here you have 0 volts again. On this BIOS chip, we have 0 volts. And this is, again, is not normal. Wait, here is Rosin. Do you think anyone play with this BIOS chip? Wait, 1 second. Why I have a power button? Why I have a button on the BIOS chip pin? Oh, because this is ground. Okay, that's ground. Okay, got it. Here I have 1.6. Here I have 0. Here we have 0. Here we have 0. Here we have 0. Why I have a PD controller with no voltage on it? Okay, let me try something, yeah? Let me try something. Probably it's not 1.8, probably it's 3.3. Well, let's try it. Little bit of current, just a little bit. Good. And I'm gonna come on the BIOS pin. This is not BIOS, it's a memory. So here we have, no, it's nothing. No, it's taking no power. Okay, let's raise the voltage to 3 volts, 3.3. And it's taking 150 milliamps, and that's bad. That's proper bad. Why 150 milliamps? Huh? Yeah, 150 milliamps. You know what? I have a feeling I'm not gonna see the swimming pool today. Yeah, it's making no sense. I mean, why the laptop? Why the PD controller is working if we have no voltage on the PD controller memory chip? How you can explain that? Huh? No, you can't explain it. No, you can't. No, a working PD controller with no voltage on the BIOS chip, on his memory chip. No, you can't explain it. No. And yeah, you're right. It's very easy. One wire from here to here. Yeah, just passing the 19 there, and yeah, problem solved. More than that, the laptop is charging fine, working fine, no issues. If I fix it the way I want it, the people will say I'm dodgy, right? Yeah, like usual. Okay, so I mean, for me, it looks like here someone worked. I swear, it's looking like. Wait 1 second, that's liquid damage? This is liquid damage here? I can see some rust here, some oxidation, but that's all. I can see some oxidation here, you can see it? Yeah. You know what? I think we have to take the board out because it's very possible to have liquid damage on the other side of the board. But one more time, liquid damage is not our concern right now. Our concern is why something is taking current on the BIOS chip power rail. So on the pin here, it's taking 150 milliamps. Let's see what is taking that current. 150, good. And what is taking that current here, what is that? Wait 1 second, what we are seeing there? So I'm coming with current here. I'm coming with current here, and what is getting hot, it's actually something else. Check there. Here's something. Ah, that's a switcher. Yeah, that one is a switcher. Yeah, 3.3 volt switcher. And this one is meant to provide voltage to our memory chip, PD controller memory chip. So plug in the charger. Let's check the voltage on that switcher. So here we have nothing, right? Yeah, nothing. Here we have nothing. And here we have nothing. Okay, let me plug the battery. The battery is plugged, and here we have 0. No, this is shorted. Okay, so here we have 130 milliamps. Here, check here on this pin, 150 milliamps. Yeah, this is gone. This is shorted. Nothing to see here. No. Okay, so the switcher is out. What this is doing is switching 3.3 on and off. 3.35 volts depends what this is doing. So if I plug the USB, so here we have 0, here we have 0, here we have 0. Okay, I don't like that. Coming with the power supply, here we have, it's still taking current. Check that, 130 milliamps. And here it's taking nothing. Yeah, this is the output of the chip. And here it's taking 130 milliamps. Okay. Let's see what is taking 130 milliamps. Yeah, I know the battery is connected. I know that. I like living dangerously here. 130 milliamps. And what is taking 130 milliamps? I have no idea what is taking that kind of current. The CPU RTC line. But it's interesting, the CPU is still working. Okay. Let's try different tricks, yeah? We took out that switcher. Yeah, we don't need the GPU or fans. Battery is still connected. 5 volts. Let me switch on the laptop. No, it's not coming on. You know, actually, that switcher can be good. Yeah, can be good. It's taking one of the input or output is taking 150 milliamps. Yeah. 19 volts. Okay, let's check one more time. So here you have 3.3. Check that on the screen. Yeah, 3.3. And here we have 2.4. Why you have 2 volts here? 2.2 volts instead of 3.3. 2.2. You ever seen 2.2 volts on a laptop? And if I'm shorting the 2.2 with 3.3, what do you think it will happen? Because that's what the switcher is doing. So shorting the 3.3 with 2.2 and the voltage is 3.3. Okay, that's not bad. 2.2, and on the BIOS chip, on the memory chip, we have 2.2. Why will have 2.2 on this memory chip? Why this chip is outputting, this TPS is outputting 2.2? Let me come with the power supply. Let's try. Let's see what is happening here. 3.2. So we have 3.2. 3.2 exactly here. And it's taking no current. So actually it's no issue here. You know what? I'm gonna solder back that switcher because I don't think it's faulty. No, I don't think it's faulty. That's crazy. So now we have 3.3 on the BIOS chip. You can believe that, on this memory chip. We didn't have 3.3 before. Now we have 3.3. But still, no working. It's not charging. Main power L0. Okay, so what we are doing? Soldering one wire from here there. Now we have 3.3 on this capacitor. Here you have 20. Here you have no voltage. So this is the output. Definitely this is the output. You know what? Let's prove it. Let's prove that's the output. So beeping the current sensor here is not beeping. Oh lol, so this is not the output. Huh? This is the output? No. This? No. Okay. Okay, so that's not the output. Good. Let's take the board out. We are missing something. It's something between this current sensor from here to here is something in between, and I don't know what. Yeah, let's take out everything. Why we are taking the board out? 1 second. What we are doing here? This is not meant to charge through the USB-C. No, we forgot why we replaced the PD controller. We replaced the PD controller because the PD controller was not speaking with the AC chip, and the laptop was not coming on. But this one, it's not gonna charge. No, this is, I seen the charging board. It's like, what? You know what? I don't remember. I forgot. I can't believe. I'm pretty sure that port is not charging. It's not meant to charge. Okay, so coming with 19 volts. 19 volts. Here. Charging fine. It was charging fine before? I'm not sure. 2.8 amps. The laptop is coming on. 2.7. That was our issue. The laptop was not working. That's why the customer sent it. Wait 1 second. Yeah, check there. It's taking current. Probably it's not coming on because I took out every wire. We took out the keyboard. Where is the power button? The power button is not on the keyboard. But it's coming on by itself. Yeah, and it's working fine. That was the issue. I mean, why we are wasting time? This is not meant to charge for the USB-C. Yeah, it's working fine. I mean, this is insane. We forgot, why we start working on this job, on this laptop. We forgot the initial thingy. It was not working on the... Okay, so the laptop is charging and working fine. Yeah, that's why we replaced the PD controller, because the laptop was not coming on, because that little prick is speaking with the AC chip. It's one way to check if the PD controller is working, yeah. Yeah, I'm gonna show you which way. Yeah, don't worry. So plug in the battery. Now we are not plugging the charger anymore. We are plugging a USB-C. Check here, we have... No, not this one. We have this thingy. This has a light somewhere? No, my one has a light. Yeah, this one has a light. 1 second. No, okay, this is no USB-C. Okay, plug in this, and we should have 5 volts. 100%, we should have 5 volts there. On this pin here, check on the screen, we have 5 volts. 5 volts. That means the PD controller is supplying power to the USB-C. Means these pins are the output. Check on the screen, 5 volts. You can see? Yeah. Okay, we fixed it. Yeah. Well, it's working. I mean, the laptop is on, right? Yeah, it is on. Yeah, it's fine. Don't worry, it's fine. You know what I'm gonna do now? Go back to swimming pool, and I'll put it all back together after that. I mean, this is insane and crazy. I mean, how long we work, on this job for no reason. Because when I start taking the things out, I realize that here are screws, and the screws are on the charging port. So this is the charging port. Yeah. I'm not even going to check if that port is charging or not, because I'm pretty sure we replaced that chip which was faulty. Yeah? We feed back the switcher, which is fine. Yeah, we went on a rabbit hole just because, the laptop was working fine. That's no issue. Well, yeah, we thought it's faulty. Anyway, I'm gonna stop now. I will say thank you for watching. Like, subscribe if you like the video, and try to be gentle. I think I'm getting older. Anyway, see you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.